Hi class, this is me, Mr. Morris. This is our first set of notes in AP Chemistry that we're going to be doing this year. One thing I want you to do when you're taking notes, and this year because of the way things are, the way in which you're taking notes will be different from one person to the next. You may be doing this by annotating on a screen. You may be doing this writing on this. It's possible that you're going to use PowerPoint or something else where you can insert a text box. Whatever the case is, I want you to number it somewhere. If you're taking notes in a way that you can write anywhere you want, I'm going to be putting the number at the top right-hand corner of the notes. Okay, I'm just going to put the number 1 here because this is our first set of notes. All right. Measurements and calculations, we've talked about this in pre-AP chemistry, but we're going to go just a little bit deeper, and I think this is an important review. First, we want to talk about uncertainty in measurements, which we did this last year, but it's just an important reminder. When we're taking measurements in science, scientific measurements are reported so that every digit is certain except the last one, which is estimated. So if we look at all of these numbers, there's only one of these that is estimated, and it's the last one. So this is the one that's estimated. Every number that's before it is certain. Okay, so what we're saying is we're sure of these. This is our estimate. The smallest measurement between two markings is called the increment, so we use that word a lot in chemistry. If a measurement falls between two lines, let's say we're reading graduated cylinders as down here. If it falls between two lines like this one on the right, we're going to estimate the last digit. We're going to guess what that number is. You can see that we don't know exactly what it is, so we've got to estimate. And if the measurement falls on the line, then the last digit is going to be 0, because that tells us that we know we know very, very close. That must be a 0. Okay, it's very, very close to exactly, in this case, 14.4. Okay. Precise readings have to have 1 extra decimal place beyond the increment. This is very important. It's really important that we get that concept, that you're always going to have 1 extra decimal place beyond what the increment says. Also, make sure you're reading the meniscus on the graduated cylinder properly. You're going to read at the bottom of the meniscus. Never look from above, looking down, and never look from below, looking up. You're going to look at eye level and read the bottom of the meniscus. So some examples. If I'm looking at this one, the first thing I need to do is determine what my increment is. That's going to tell me how many decimals I need in my answer. So 14 and then 15. In order for that to be true, these can't be 1. I can't go 14, 15, 16, 17, 18. So the increment is smaller than 1. It has to be 0.1. And if you count them, it makes sense. It's 14.1, 14.2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay, so the increment is 0.1 milliliters. My estimated reading is going to be 14.1234, 14.4. The biggest mistake is students will say it's exactly 14.4, so I'm just going to write 14.4. We always have to estimate that last decimal place. We always have to go 1 place farther than what the increment is. So since I have increment of 0.1, I have to have 1 extra decimal place. I need to have 2 decimal places. 14.40. All right, up here, I have 10, 11, 12, 13, 14 point something. It's because this is a jump of 10. Goes from 10 to 20, so 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then 20. That makes sense. Okay, so our increment is 1, and we have 11, 12, 13, 14. Between 14 and 15, I'm going to say 14.4 milliliters. Now, a question like this would be a multiple choice question, probably. And you would have to pick the one that had the correct number of significant figures and was reasonable. Okay. Now you might have said 14.3 or 14.5. Either of those would have been fine too, if we didn't already have this and if it didn't say that they're the same exact volume. Okay. Just make sure you're reading the bottom of the meniscus, not the top. If you'd read the top here, you would have said it was 14.50. Same thing here. It would have been 14.4. This one would have been 14.50. This one would have been 14.5 or 15.0, whatever the case is. All right, so just make sure that you're reading those with the correct number of decimal places. Now we have significant figures in multi-step calculations. This part's a little bit new. We did talk about significant figures, but we didn't really focus on what to do if we have multiple calculations. You had some of them over the summer homework though, so let's go through that. In multiplication or division, you're going to round to the least number of significant figures. We already know that. In addition or subtraction, you're going to round to the least number of decimal places. That's the one a lot of students forget, but you already know that from pre-AP chemistry. And then we have when a mix of rules 1 and 2 are used, like in these problems where we're multiplying and we're subtracting, or we're multiplying and dividing and adding. In that case, we need to follow our order of operations. So the sig fig rules take priority in the same order as order of operations, which is PEMDAS. Parentheses, exponent, multiplication, division, addition, and then subtraction. Okay. So when I look at this, the first thing that I see out of PEMDAS is parentheses. So whatever's in parentheses needs to happen first. And I need to follow the sig fig rules for that. So I need to subtract those numbers. I need to go 75.49 minus 75.01 to get 0.48. That's what's in the parentheses. So I just solved for that. Then I have 6.78 times 5.903 times 0.48. Okay, and you notice the way that I did that with significant figures, I'm following my addition subtraction rules. I need to conserve the lowest number of decimal places. This has 2 decimal places, this has 2 decimal places, so my answer should have 2 decimal places. Okay, now I'm going to multiply, and you're going to follow the multiplication division rule, the least number of significant figures, which would be how many? Well, this has 3, this has 4, and this has 2. So I'm going to keep the least number of significant figures. That would be 2 significant figures. 6.78 times 5.903 times 0.48. I get this number, but I need to round it to 2 sig figs, so that's going to be 19. That's your answer. Okay, looking at the next one. Parentheses also includes brackets. We want to start in the innermost parentheses. Now this is actually scientific notation, but it's 3 significant figures. Then I'm going to divide by this, which is 1, 2, 3, 4, 5 significant figures. So I'm going to keep 3 significant figures when I do that operation. Okay. So I need to do what's in parentheses first. 2.87 times 10 to the 6th divided by 4,853.3, and I get that number. I need to keep the least number of sig figs, so I'm going to keep 591. Check the next one, it's below 5, so it's just 591. In the brackets, that's what I have is 591, and I'm going to add 144.99. Now, what's the least number of decimal places between those numbers? No decimals, just the whole number, the ones place. So when I add these up, I'm going to make sure that I round to the nearest whole number. 735.99, that's going to round up to 736. And that's your answer for that one. All right, now you've got some practice going over how to correctly measure to the correct number of significant figures to the correct amount of uncertainty, and then also to solve some problems with significant figures. Work on that for a little while.